At the outset, the team at AIMS Bhopal, myself, Dr. Sunaina Karna, Dr. Shikha Jain, and Dr. Pooja Singh, we would like to extend our thanks to the team at Indian College of Anesthesiologists for involving us in this prestigious activity. So today we are going to have four sessions on safety features of Anesthesia Workstation. And each of these sessions is going to be preceded by a pre-test of 4 to 5 questions each. So we would like all of you to participate in the pre-test. It will be held in the form of a poll, and we will discuss all the poll results at the end of the entire seminar. So without any further ado, I will introduce all the speakers when they are about to present. So can you all see my screen?
Yes, ma'am.
Okay. So before starting the session, I would directly like to go into the poll for the session 1. So can we have the poll, please? So question 1. Which of the following is not a component of a high pressure system? Primary pressure regulator, option A. Option B, secondary pressure regulator. Option C, cylinder pressure gauge. And option D, cylinder pressure indicator.
So 30-second overs. I'm ending the poll.
Okay. So we'll go on to the next question. Rupsa, we'll discuss all the poll results and the answers at the end. Is that okay?
Okay, ma'am. I have launched the second poll.
Yeah. So the second question, for oxygen, the primary pressure regulator regulates pressure from 2000 psig to 50 psig. Option A. Option B, 50 psig to 2000 psig. Option C, 745 psig to 50 psig. And option D, 50 psig to 745 psig.
So the time over.
Can we give them a few more seconds, Rupsa? I think this is a longer question.
Actually, ma'am, for that I need to relaunch. Should I relaunch it?
Yes, just relaunch
Okay,
it for
okay.
another 5-10 seconds.
Ma'am, just tell me when to stop.
Okay, I think we can go on to the next question. So coming to question 3, which of the following is a reclosing type of pressure relief device? Rupture disc, fusible plug, combination rupture disc or fusible plug, and fusible plug, and option 4, pressure relief valve. So all of these questions, they have only one single answer. So we need you to mark one single answer out of these questions.
So the time is about to over.
Okay, so going on to the next question. Which of the following is a property of Bodoc seal? Non-combustible neoprene washer with a copper ring. It is a combustible, option B, combustible neoprene washer with a copper ring. Option C, combustible copper washer with a neoprene ring. And option D, non-combustible copper washer with a neoprene ring.
Second is about to over. So, ma'am, should I stop or keep it for a while?
Yes, I think you can stop. So going on to the last question of this session, pin index for oxygen, nitrous oxide, and air are 1525 and 35 respectively, 1535 and 25 respectively, 2535 and 15 respectively, 2515 and 35 respectively.
Four seconds left. And the time is over. All 5 questions are done for session 1.
Thank you, Rupsa. So going on to my talk now. So today I will be talking on overview and safety features of the high pressure system, and my colleagues will be talking about the intermediate, the low pressure system, and criteria for obsolescence for anesthesia workstations. So now, just to give you a brief overview, I'm sure all of us are already familiar with the workstations. We know that these are continuous flow type of workstations, and they control both flow and pressure of gases from cylinders or pipelines which supply these gases to the patients. These workstations, they pass them through a vaporizer and deliver the mixture to the patient through a breathing circuit, right? So now what is the difference between a Boyle's machine and a workstation? We know that a workstation integrates each and every component. So you don't have anything that is separate from the workstation. We have the anesthesia machine, that is the main part of the machine which delivers the which gives the anesthetic, it delivers the anesthetic agent per se, the ventilator, the vaporizer, the breathing system, the scavenging system, the monitors and the data managing system. So everything is integrated into one single unit. So you don't have different connections. There's less possibility of misconnections. And there are a lot of other advantages of workstation. So we are able to, it helps a lot in meeting the goals of the patient, that is ensuring oxygenation, ensuring accurate delivery of anesthetic vapors, appropriate ventilation, and reduction of exposure to the personnel inside the operation theaters. So a few lines about advantages and disadvantages of workstation. So we know that there are a lot of built-in safeguards, and there is a system of automatic checkout. We have reduced external connections, so a lot of possibility of disconnections or switching of the ventilator that was there earlier is now not there. We have integrated alarms and screens, so you have a lot of data, patient data, which is easily accessible to you, and there are a lot of built-in safeguards. But there can be a time when there is a failure of display. There can be an electronic failure. These systems are complex, so you have to be very well versed in the working of these machines. Also, you can have a lot of unrecognized errors because you may not be aware of some of the errors and the proper functioning of the machine. So that is why it is a must for us to know what parts of the machine help you keep your patient safe. So why we need to know the safety features is because there are some hazards associated with the machine and with the gases that we are using. So we know that there is a cylinder which is at very high pressure. There's a possibility of explosion. Earlier, there used to be some errors, some incidences of fire in the operation theater. Then a lot of human errors can take place. For example, delivery of a hypoxic mixture, delivery of a very high pressure to the patient. So these all can be traumatic to the patient. So what we'll be talking about are the minimum safety features which are needed in an anesthetic machine. But there are certain other features that also you must be aware of. For example, electrical safety. Then at in different conditions, whether your data or your results, they are reliable or reproducible or not. So the ultimate responsibility for safe use is the anesthesia provider who's providing the anesthesia. And we have to be aware of the proper usage and the proper standards with which our machine and each and every step that we're taking in the operation theater should meet. And apart from the safety features that are inbuilt in the machine, we also have to be aware of the proper usage and standards. So the standards that every machine should meet, it is governed by the American Society of Testing and Materials, that we recommend that the machines should be obeying those standards. So before going into the machine, we'll just revise quickly the pressure conversion units. So we all know that 1 atmosphere is equal to 1 bar. It is equal to 760 millimeter mercury. It is equivalent to 100 kilopascal and 14.7 psi. So coming to the components of the anesthesia workstation. So there are electrical components, mechanical components, and pneumatic components. So the electrical components include the master switch and the power failure indicator. So you can see in this machine, there is the master switch. This is a Drager Primus machine. So all of you must be you have to go and check. Sometimes we rely too much on the technicians. And if the technician is not there, we cannot even switch on the machine. So that is not a very good practice. So we have to know each and every part of the machine. We also should know certain troubleshooting. So this is the master switch. This is the power indicator. This is the battery indicator. So at present, you can see the green LED over here, and it shows that your machine is plugged in and charging. Okay. So we have the master switch and the power failure indicator. They are both visual and audible. We have reserve power. So you should know how much reserve power your machine has. Most of the operation theaters, they now have a central UPS. But you should also know whether your machine has an individual reserve power or not. Suppose the central supply goes off and there is no UPS in your machine and you don't have a central UPS also. Then you might land up in a suit, right? So it is recommended that if there's no, if the machine is running on reserve power, then you should switch to manual ventilation or spontaneous ventilation to conserve power. Then there are electrical outlets, and it is recommended that only devices which are pertaining to the machine, for example, the ventilator, and only those devices which are, and the monitor screen, these only should be connected with the electrical outlet, and no other external device should be connected to the back of the machine. Then you also have to see the electrical outlets, they're mostly present on the back of the machine. So just go and have a look once on your own machine. Then we have circuit breakers and data communication ports. Again, they are present at the back of the machine. And in the off state, even when the master switch is off, the battery charger and the electrical outlets are functional if your machine is on charge mode. And once you power the machine on, the electrical, mechanical, and pneumatic components get activated. So on powering on, each machine will go to a checkout procedure. You can bypass this checkout in an emergency, and after checking out, you can put the machine on standby mode. But it is recommended that after every 24 hours, the machine should be turned off and complete checkout should be done. So what are the safety features? So we can see that these workstations have made our life a lot easier. So I would say that each and every part of the machine is designed in such a way that it adds to the safety of the machine. But to be specific, the master switch, the power failure indicator, the reserve power, all these are safety features. So suppose it is all intuitive, right? So the circuit breaker, suppose there's an overload, there's the electrical overload. So circuit breaker will help that the machine will not get damaged, and the you have to decrease the load. If suppose there is there's an overload, then you will the circuit breaker will break the supply, and you have to reduce the electrical load and then restart the machine. If there's any error in the machine, you can take the data via the data communication port and send it to the company. So this is also a safety feature. Then these checkout procedures, mandatory checkout procedure, putting the machine on standby mode for fast boot up, bypass in an emergency. All these are safety features of the electrical part of the workstation. Okay. So coming to the high pressure system per se. So we all know that high pressure system, it extends from the cylinders to the primary pressure regulator. So just after the primary pressure regulator, the intermediate pressure system starts. So we will concentrate on the high pressure system for now. So what are the components of the high pressure system? So we know that cylinders, the hanger yoke assembly, the pressure indicator or the Bowden gauge, the pressure regulator or the pressure reducing device, and the yoke block, they are parts of the high pressure system. So we know that they work at very high pressures. So for oxygen, 2000, around 2000 psig, so roughly 2200, but you can remember around 2000 psig, and 750 psig for nitrous oxide. So what are the safety features of these components? So there are different safety features for cylinder, for the hanger yoke assembly, for the cylinder pressure indicator, and for the pressure regulator. So first, we will look at the safety features of the cylinder. So as such, cylinder is not a part of the workstation, but it is an integral part of the workstation in that it cannot be used, the machine should not be used without a cylinder. So that is why I have included the cylinder also in this discussion. So we all know that there have been a lot of incidences of wrong cylinder being connected to the workstation. So that is why the safety features of the cylinder, they all focus on avoidance of wrong connection or wrong cylinder being connected to the workstation. And they have recently or over the past 10 years, I looked up on the internet, there have been very few incidences of wrong cylinder connection. And pipeline connection, yes, a few incidences have been there. But because of all these color coding, cylinder labels, gas symbols, and use of an index safety system, the incidences of cylinder misconnection have gone down. So let us look at these in detail. So all the manufacturers of cylinders, they got together and they introduced various safety features. So all caps, hoses, connectors, knobs, pressure gauges connected with the set gas and the cylinders, they are all color coded. So the main three gases that we should be concerned about are oxygen, nitrous oxide, and air. So we should remember that oxygen has a black body with a white shoulder. We all work with it every day. So I don't think it is very hard to remember. So nitrous oxide, those blue pipes we see every day. Then air is white and black, we know. So the shoulder is also white and black, and the body is also white and black, and vacuum is yellow. So all of us are familiar with these colors in our operation theaters. Then what about labeling? So each and every cylinder has to have a label, or it is also called a decal. So this label has to have the name and the chemical symbol of the gas. For example, in the top label, you can see that nitrous oxide is written. It is written medical gas and only treatment only. Nobody can take it without a treatment, without a doctor's prescription. Then there's a hazard warning on a diamond shape figure. So you can see this diamond shape figure and you can see the class of the gas. The name and address of the cylinder manufacturer. You can see it is distributed by so and so person over here. And then over here it is written. Then each and every cylinder should also have a tear weight. It is usually stamped. That I'll go in the next slide. And directions for use and cylinder size photos should also be mentioned. So this figure is given in Dorsch, and this marking on the left is Department of Transportation. This is actually the US standard. I'll also show the Indian cylinders. Then 3Al, it stands for aluminium. So you can also have some other cylinders, which I'll talk about later on. Then 2015 is the PSIG rating. So for the tank, then we have the manufacturer's identification on the right and the date of manufacturer on the extreme right. So, but these are not the Indian standards. So I went and saw our own cylinders and I spoke to the gas person involved in our hospital. So these are the markings that are present on our cylinder. So as you can see, this is an oxygen cylinder and medical oxygen. The markings are not very clear, but here you can see MO2 is written. This is medical oxygen. Then this is the name of the manufacturer. And 150 bar, here it is written 150 bar and here it is written 250 bar. So 150 bar is the usual pressure, which is around 2200 PSIG. And 250 bar is the pressure at which it has been tested. So the maximum pressure it can hold is 250 bar and the usual pressure is 150 bar. Then here you can see this is the serial number and this is the tear weight. Tear weight is the weight of the cylinder when it is empty. And this is the amount of water that it can hold. The 46.7 liter is the amount of water. IA stands for the Indian standards, and this is the standards that the cylinder is meeting. Okay, and at one place there's a date. Yeah, so this is the date 0520. So each cylinder has to be retested 5 years after the original test. So this is the date. After 5 years after this date, it has to be sent again for testing to the manufacturer or to the testing agency, and they will again stamp it with the date of testing. So we all know that all cylinders, the usual cylinders that we are using in our theaters and for transport are E-type cylinders present at the back of our workstation. They are A-type and they have 660 liters of oxygen and a pressure of 2000 to 2200 PSIG. For nitrous oxide, the pressure is 745 PSIG. And you can go through the various classification of cylinders. Then what are the, coming to the cylinder parts. So the body is made up of, just one second. Yeah. So the body is made up of steel or carbon steel. So nowadays carbon steel is used because it is lighter in weight. For MRI, we have aluminium. So it is very light and it is MRI safe. So you can have these three markings. So 3AA stands for aluminium and 3ALM stands for aluminium and AA stands for steel. So if you have AL or ALM, it means that your cylinder is of aluminium. Then the cylinder has a flat or a concave base so that it doesn't topple over. It has a valve, which is a spindle valve made up of either bronze or brass. And this valve, it has a port, a stem, and a diaphragm. There is a specific type of valve which I'll be talking about. Then it also has a pressure relief device. So as you can see in this figure, there is a conical depression, and this is the port. The back of the valve, it has this conical depression and the pressure relief device over here. The port, as you can see here, it is covered by a washer. That is how you identify the port. And the part of the cylinder which attaches to the yoke assembly through which the gas enters the machine is called the nipple. Then you have these holes for the pin index system. So we have two type of valves, either packed valves or diaphragm valves. So what do these valves do? So these valves, they help in sealing the cylinders against any leaks. So packed valves are direct acting and they withstand very high pressure. So when you see your cylinder and if it opens after 2 to 3 turns, then you can understand that your valve is a packed valve. There are some newer type of valves called diaphragm valves, which have only half to, you need only half to 3/4 of a turn. You don't even need one full turn to open the valve. Okay. So as you can see, these are based on the principle that, so you can see this diagram. This is also from Dodge. It is given in Dodge that there is a packing nut and there is a body of a valve. So when you screw this valve, the packing nut, it turns and it ensures a gas tight seal. So similarly, the diaphragm valve also works on a similar principle. So turning the handle clockwise, it forces the diaphragm downwards and closes the seat. Then on the other hand, once you open the valve, the upward force of the spring opens the seat. Okay. Then the important part of the cylinder is the pressure relief device. It is an important safety feature. So you have three types of safety pressure relief devices. So you can have a ruptured disc, a fusible plug, or a pressure relief valve. So what is a ruptured disc? So it is a non-reclosing type of device. What this means is once it bursts, it cannot be closed again unless it goes to the manufacturer. So it guards against a high pressure, a high temperature, or overfilling. So it is a very effective kind of pressure relief device. So fusible plug, what does it do? At very high temperatures, it will just melt and it will help discharge the cylinder contents outside. So if there is very high temperature, so as you can see in this diagram, so this is a ruptured disc. So if the pressure is very high, then this disc will rupture and all the gas will escape through the discharge channel. Okay. Then there's a combination ruptured disc and fusible plug, which will respond to both excessive heat and pressure. The temperature at which it will rupture or melt, it is called the yield temperature. Then some newer cylinders, they have reclosable type of pressure relief devices. So there's just a valve. So at a certain set pressure, the valve will open, as you can see in this diagram. The valve will open and it will allow the cylinder's contents to be discharged, and the valve will then close again and the discharge channel will be closed. So the advantage of this pressure relief valve is that it is reclosable. So even if you have high pressure, some of the gas will be discharged, but the entire cylinder will not be destroyed. Okay. So as I told you earlier, it is not just the safety devices or the safety mechanisms that are inbuilt into the system. It is also how we use it. So only one cylinder should be open at a time in the machine. We should check the cylinder and the pins while we are attaching the cylinder. We have to remember that the conical depression is on the opposite side of the pin index system and the nipple part of the port part of the stem, okay, of the valve. So we should not be inserting the hanger yoke assembly into the opposite side, because if you do that, then the cylinder might get damaged. Then there should be no grease while we're attaching, because grease can act as a flammable agent. Cylinder should be closed when not in use. And when there's no cylinder, it is recommended to attach a yoke plug so that there is so as to minimize the possibility of a leak. So coming to the second part of the high pressure system is the hanger yoke assembly. Again, as I said, each and every part of the hanger yoke assembly is designed in such a way so as to be a safety feature. So the hanger yoke assembly consists of the body, the swinging gate. So this gate, it swings like this and it keeps the cylinder tight into its place. There's the nipple through which the gas enters. We have the index pin. These are the index pins. You can see this is very faint, but you can see over here. Then we have a Bodog seal. So every nipple has to be covered by a non-combustible neoprene washer with a copper ring. So what is neoprene? It is a material which ensures a gas tight seal, and it is a very durable material. That is why they're using this neoprene into this valve. Then why there's a copper ring? So copper is corrosion resistant. So that is why copper is used to as a part of the Botox seal. So each and every part is a safety feature. Then a particulate filter is there so that inadvertently, if there's any particulate matter into the gas, it is of size 5 micron. So anything above 5 micron will not go into the system and damage your machine or be delivered to the patient. Then we have a check valve assembly. So why we need a check valve assembly is so to ensure a unidirectional flow. Suppose you don't have any cylinder over here. So if the pressure in the machine rises, what it will do? It will push the plunger and ensure that the yoke assembly is closed. So it is also recommended that, and this check valve might be incompetent sometimes. So that is why, and you may not come to know of it. That is why it is recommended that no yoke should be remaining open, and you should always attach a yoke block to your yokes. Then the most important and the system that is often asked, and we are very familiar with the system, is the pin index system. So we all know that below the outlet port in the yoke, in the body of the yoke, there are holes. So these holes, they correspond to these positions, which are arranged in an arc of a radius of 9 pi 16 of an inch. That this is a little theoretical, but you have to remember that these pins, they have their own place. Okay, they have their own orientation. So as you can see in this diagram, there are 6 possible combinations, 6 possible places, and the 7th one is in between 3 and 4. So all the gases are now designated by their index pins. So if you want to remember, then the 3 gases you can easily remember. You can start with air. So air is 1,5, oxygen is 2,5, nitrous oxide is 3,5. So 1,5, 2,5, 3,5. Oxygen, air, oxygen, nitrous oxide. So the pins are present in the yoke assembly and the corresponding holes are present in the cylinder. So no cylinder comes without these holes. So whenever the corresponding pins and the pin holes, they align with each other, they will fit. For example, you can imagine an example of a USB device. So whenever it has a proper USB port, it will just go and fit inside it, right? So similarly, these pins and these holes, they correspond with each other. If they correspond, then only they can fit properly into the cylinder can fit properly into the machine. So, but we should know that it is not a fail-safe mechanism. So there are certain fallacies. So what are the fallacies? Suppose your cylinder itself is filled with the wrong gas, or your pins are broken, or there have been reports in which more than one washer has been attached and the pins, they don't align that well. Still, some of the gas is delivered into the system, or there can be certain other manufacturing defects. So that is why you should be also use, that is why we have safety features at every step. It is not just dependent on pin index safety system or any one feature. Okay. Then we have a cylinder pressure indicator. So we all know from the Boyle's machine, we are very familiar with this. It is a Bowden gauge and it is a hollow bent tube. And whenever this tube is pressurized and there is pressure, it straightens, and the pointer it reads on a scale which is either kPa or PSI. We now have digital pressure indicators as well, and you can see exact pressure indicators. For example, in Bragger Primus on the checkout page, and also there's a place on the ventilator screen where you can see the pressures of the cylinders. Okay, so this Bowden gauge is also it is designed in a way that this cannot the rating the Bowden gauge can read 1.5 times of the service pressure. Then whenever earlier there have been incidences of explosion of this Bowden gauge. So it is designed in a way that it will not explode from the front. It will always explode from the back. So this also has inbuilt safety features. Then coming to the pressure regulator. So the pressure regulator in the high pressure system is the primary pressure regulator. So it is built on the principle that P1A1 is equal to P2A2. So in the machine, so if you can see that a high pressure on a small area. So in the cylinder, there's a high pressure and there is a smaller area. In the machine, there is a larger area. So it will get balanced with a low pressure. So a spring is added for a constant flow and a low pressure output. Then we have to remember that it is always preset to a lower level than the pipeline, so that preferentially your pipeline is used and the cylinder is not exhausted. Okay, so in this old machine, you can see that this is the Bowden gauge, this is the yoke assembly, then this is the primary pressure regulator. So after the primary pressure regulator, then only the gas will enter into the tubings. So this was all, you can see this is a close-up of the primary pressure regulator. In the newer machines, it is not possible to see the primary pressure regulator as such. So these are my references. You can go through Dodge, this very nice article in Indian Journal of Anesthesia. And there were, in fact, 2 articles in Indian Journal of Anesthesia, and I'm sure all of you are already aware of these articles. Then, this is all regarding the high pressure system. So coming to the intermediate pressure system. So before we start, I would like to launch the poll. So Roopsa, can we have the pre-test questions, please? Roopsa?
Yeah.
Okay. So question 1 of the next poll is, what is not the part of intermediate pressure system in anesthesia machine? Option A, master switch. Option B, oxygen flush. Option C, flow meter assembly. And option D, flow control valves. So again, single choice answers, which we just want you to mark one option out of the above.
So the time is up. So here
Question.
I have launched the second question. Yes, ma'am, you can continue.
Yes. The oxygen flush valve gets disabled when the master switch is switched off. State whether true or false.
And the time is about to over.
Question 3. The second stage pressure regulator decreases the pressure to option A, 26 psig for oxygen and 14 psig for nitrous oxide, 26 psig for nitrous oxide and 14 psig for oxygen, 35 psig for nitrous oxide and 50 psig for oxygen, 50 psig for nitrous oxide and 35 psig for oxygen.
And the time limit is over. Ma'am, should I? Okay.
Yes. So question 4, oxygen supply failure alarm is activated when oxygen pressure falls below a safe threshold value within 5 seconds and can be muted, option A. Option B, 5 seconds and cannot be muted. Option C, 10 seconds and can be muted. Option D, 10 seconds and cannot be muted.
5 seconds left. The time is over.
So last question. Which of the following part of the anesthesia workstation are not independent of the master switch? Option A, oxygen flush. Option B, auxiliary oxygen control. Option C, auxiliary flow meter. Option D, flow control knob.
And the time is over.
So here I'd like to stop sharing for a minute. And I'd like to hand over the proceedings to Dr. Shikha. I'll just introduce her. 1 second. So if anyone has any questions, I think they can put in the chat box, right? Group C?
Yes, ma'am.
So do we have any questions till now?
No, ma'am. If I receive any question, I will be posting it in the Zoom chat box.
Okay. So can you see can you
Yes,
see the
ma'am.
screen, right?
Yes, ma'am. We can see the screen.
So for the second part of this webinar, which is safety features of the intermediate system, it is my pleasure to introduce Dr. Shikha Jain, who is an assistant professor at the Department of Anesthesiology at AIIMS Bhopal. And her areas of interest are transplant anesthesia, regional pediatric and onco anesthesia as well. And she is a very good friend of mine. So I already know all about her, and she has many publications in national and international journals, has an extramural grant by ICMR as well. And she is also an awardee of the European Diploma of Anesthesiology and Intensive Care. So over to you, Dr. Shikha. She'll be talking on intermediate system of the anesthesia workstation.
Thank you so much, ma'am, for a wonderful welcome of me. And I really want to thank you for the opportunity for this prestigious talk. So I'll be coming over to intermediate system in anesthesia workstation. In this anesthesia workstation, we are just have to remember this diagram. See, according to this diagram, what we are saying, it is a pressure system. High pressure, intermediate pressure, and the low pressure. High pressure, as told by Dr. Zainab ma'am, it consists of cylinders, the pressure gauge, and the primary pressure regulator. It works at the 2000 PSIG for oxygen and 745 PSIG for nitrous. Then we have intermediate pressure, which operates at 35 to 50 PSIG for intermediate pressure system. And it starts with, see, we can see the pipeline pressure, pipeline inlet, the pressure gauge, the fail-safe valve, oxygen supply failure alarm, the second stage pressure regulator, the oxygen flush valve, the pneumatic part of the master switch, and it ends at the flow control valves. So, and then comes the low pressure system. Low pressure system, what is low pressure system? This system is further reduced to 40 PSIG for oxygen and 26 PSIG for nitrous. Finally, why there's so much reduction of the pressure? Because there's a high fluctuant pressure, which can cause barotrauma to the patient. So through primary pressure regulator, it is decreased to from 2000 PSIG to 35 to 50 PSIG. Then through primary pressure regulator, it is further reduced to 14 PSIG for oxygen. And then finally, it is coming out as 5 PSIG. Basically, as a working medical gas, we have to decrease the pressure. So what is intermediate pressure system? It receives gases from the regulator, which I told you, the primary pressure regulator or the hospital pipeline at the pressures of 37 to 55 PSIG to the flow control valve. This is intermediate pressure system. So the purpose is to provide and deliver a reliable source of breathing gases at a stable and known working pressure to the low pressure section of the gas supply system. So what all it includes? Pipeline, the pneumatic part of the master switch, the pipeline inlet connections, the pipeline pressure indicators, the piping. What is piping? Piping is nothing. It is just the connection. When from the pipeline inlets to the flow control valves, there's like connections. The pipeline, it has to be strong enough to hold the pressure of this high pressure of this intermediate pressure system, and it has to be 4 times stronger. So the leak should not be more than 25 ml when intermediate pressure system is involved. And if you're involving the yoke assembly also, the leak should not be more than 150 ml. That is why this piping has to be 4 times stronger. Then it has the gas power outlet, the oxygen pressure failure valves, like we have fail-safe valves, then auxiliary power outlet, the oxygen supply failure alarm, the flush, the second stage pressure regulator, and the flow control valves. Master switch, pneumatic component. Whenever the master switch has both the components, the electronic and the pneumatic. So when you turn on the master switch, it activates both the pneumatic and electronic components. However, when we are doing the electronic component, the pneumatic component can be overruled. And it is always downstream of pipeline and cylinder inlet. When the master switch is turned off, the pressures in the intermediate system and low pressure system, it drops to 0. However, when this sudden power breakdown, you have to remember the emergency measure, oxygen flush, and the auxiliary oxygen flow meter are still working. So you have to switch over to that. Well, coming to gas pipeline, what is gas pipeline? It is very complicating. So it has a wall mount, it has a machine ad. So this part, which is at the wall, this is called the shredder pocket. So it can be shredder socket or in the form of the pendants. Then this pipeline, all the pipelines are color coded for the safety features. And also they are flexible so that there's no kinking and the interruption of the gas supply. So this is the shredder socket and this is the shredder probe. The wall end of the pipe is the shredder probe. Then comes the anesthesia machine end. The anesthesia machine end, it also has a safety measure, the DIS, diameter index safety system or non-interchangeable safety threads. What is diameter index safety system? It is nothing. It has like two bows, then two conical, and then it has nipples. So according to the shoulders on the nipple, so it align themselves in a way that it is specific for a gas. So pipeline inlet connections. So pipeline inlet connection can be what we're using in our medical gas is the oxygen, air, nitrous, and as told by Dr. Zainab, our anesthesia machine should meet the standards of American Society for Testing and Material. And it requires that every machine should have a diameter index safety system fitting for each pipeline to provide non-interchangeable connections for medical gas lines at pressures of 200 psig. The cylinders are at a pressure of 2000 psig for oxygen. The pipelines are at a pressure 200 psig. Primary pressure regulators decrease it to 35 to 50 psig. Secondary pressure, second stage pressure regulator decreases it to 14 psig. And finally, at common gas outlet, it is 5 psig. So, also because the pressure, the gas is coming from the pipeline, it has a filter to prevent any leakage or any particulate matter coming in. And it is also provided with a check valve to prevent the reverse flow of the gas back in the system. And as I already told you, hose pipes are flexible, color-coded, and kink-proof. The pipeline pressure indicator, it is definitely present on the front of the panel of the machine. It is color-coded. You can see like for pipeline pressure, it is like in front of the machine like this. It is also color-coded. Oxygen has white, the nitrous has the blue, and the air has the checkered black and white. And in Draeger primers, we have the electronic LEDs. So the pressure, whenever you're switching on, you have to just check the cylinder pressure has to be 0 because after checking, you have to close the cylinder. Otherwise, preferentially, it will take the cylinder pressure. And the pipeline pressure should be showing as 50 and 55 psig. The workstation standard requires that indicator be on the pipeline side. The indicator has to be on the pipeline side. If the indicator is on this side, so it will preferentially dilute this. And if the cylinder valve is open, it will show the pressure of the cylinder, not the pipeline. That definitely, so our cylinder pressure, pipeline pressure gauge should be near the pipeline. If the indicator were on the machine side of the check valve, it would not give a true value. If gas pressure is coming from a cylinder via pressure regulator exceeds pipeline pressure, and if the cylinder valve is open, gas will be drawn from the cylinder. Piping, as I already told you, piping is nothing just to connect two things. So gas pipeline inlet connecting the flow control valves. So it should be able to withstand the 4 times the intended service pressure without rupturing because there is already high 35 to 55 pressure. So it should be 4 times strong enough to withstand the pressure. And leak should be less than 25 ml per minute between pipeline inlet or cylinder pressure regulator and the flow control valves. And if you're including the yoke and pressure reducing system, the leak should not be more than 150 milliliters. This is a gas power outlet. This is at the back of the machine. You must have seen something black and a nipple. So it serves as a source of driving gas for the anesthesia ventilator or to supply gas for a jet ventilator. Now coming to oxygen pressure failure safety device. Anesthesia, according to American Society of Testing and Materials, machine standard requires that anesthesia machine should be designed so that like there has to be minimum oxygen pressure. Uske bina, the machine should shut down. So minimum oxygen concentration at the common gas outlet should not fall below 19%. To detect this for the safety features, we have the fail-safe valves. So in Omeda, we call it the pressure sensor shut-off valve, and in Traeger, we call it oxygen failure protection device. So oxygen pressure sensor shut-off valve, it is based on the threshold principle, whereas in Traeger, oxygen failure protection device is based on proportioning principle. It is basically the slave mechanism, which we read in the books. So whenever this pressure falls below 25 psig, so this is a diaphragm, the oxygen enters through this valve. This moves the shut-off valve away, and the nitrous is allowed to go. Whenever the oxygen pressure falls below 25 psig, it will close this valve, and the nitrous oxide will be shut off. So in that case, what will happen? An oxygen failure alarm will be activated. Whenever the psig is less than 30 psig, an audible alarm will be initiated within 5 seconds, and you will not be able to silence it in less than more than 120 seconds, and it can't be disabled. So this was a shut-off phenomena, and this is the proportion phenomena, which is in Drager machine. See, this is the oxygen, and this is the diaphragm. It depends, like whenever the oxygen pressure decreases less than 12%, then only the complete shut-off is there. Otherwise, it proportionately decreases the nitrous supply through the diaphragm. Means only the proportion, the nitrous decreases proportionately. So, as told by me, pressure sensor shut-off valve, it is based on the threshold principle. It cuts off nitrous supply when oxygen supply falls below 25 psig, and the mechanism of action is oxygen pressurizes and holds open shut-off valve that interrupts the supply of nitrous and other gases of oxygen pressure is less than threshold settings. And oxygen failure protection device, it is based on proportioning principle. It has a gas loaded regulator. That is why it is like able to decrease proportionately. When oxygen pressure decreases, there is a proportional decrease in nitrous supply and completely cut off when psig falls less than 12 psi. So what does it do? When the oxygen pressure regulator, which is the primary regulator, and who is the slave? The nitrous is the slave. It controls the secondary regulator located in nitrous line. So, like whenever this thing is happening, and oxygen supply failure alarm is activated within 5 seconds. In older machine, there used to be something called Ritchie whistle, which everyone must have read. So Ritchie whistle is an audible alarm, and it cuts off all other gas supplies. They aid in preventing hypoxia caused by problems occurring upstream. That is the disadvantage. It does not prevent any leakage happening downstream. Upstream, what is upstream? What is downstream? Downstream, what is coming next? Upstream, what is coming? What came before? Okay. So what are the limitations of fail-safe devices? These devices work on pressure, not flow. They do not prevent the administration of hypoxia mixture. So they do not prevent anesthesia cases from flowing if there is no flow of oxygen. And they prevent hypoxia from problems occurring upstream. Upstream means low oxygen pressure in the pipeline or depletion of oxygen cylinder. But what about the flow meter assembly and anything which is downstream? And it also do not prevent hypoxia from accidents such as pipeline crossovers or a cylinder containing the wrong gas. So this is just this diagram we have to remember: pipeline inlet, pipeline pressure gauge, the fail-safe valve, the oxygen supply failure alarm. Now coming to second stage pressure regulator. This is already covered by me. So what is second stage pressure regulator? The whole purpose of any pressure regulator is just to prevent the fluctuations and prevent the barotrauma, which can be caused by high pressure flow in the patient. So you have to maintain a low constant pressure. So it is located just upstream of the flow meters so that a flow is constant at the flow meters, even if there are fluctuations in the pipeline pressure. It supplies constant pressure to flow control valves and proportioning system. It receives gas from the pipeline inlet or the pressure regulator and reduces it to further 14 psig for oxygen and 26 psig for nitrous. Whole purpose for every pressure regulator is to eliminate the fluctuations which may occur in pressure supply to the flow indicators due to pressure fluctuation caused by pipeline pressure. So oxygen flush valve. This is a flush or emergency oxygen whenever there's power shutdown and you are not able to ventilate, just switch on the oxygen flush valve. It supplies 100% oxygen at high flow of 35 to 70 liters per minute directly to common gas outlet from the source, from pipeline or the cylinder, and it bypasses all the intermediate parameters and the vaporizer. And for a safety mechanism, it is placed in a recessed setting, and it is like one timer. One timer means as soon as you remove your finger, it will get deactivated. But it also has disadvantages. If you're continuously pressing in the inspiratory phase, it may cause a bladder trauma. It can also cause the dilution of inhaled anesthetic agents. And whenever you're pressing this oxygen flush, there may be back pressure in the machinery circuit. There may be changes in the vaporizer output or the flow indicators. So it is like very deliberately made as a single purpose self-closing device. It is permanently marked, designed to minimize accidental activation, and is a ball and spring mechanism. Now, coming to next is alternate oxygen flow meter. Everyone has seen like alternate oxygen flow meter, which can be used. It allows the use of low oxygen device and independent breathing circuit. Flow meter is attached before pneumatic power switch. The source of oxygen is same as other oxygen flow control valve. Newer machines, for example, Datex Omeda, have a separate standalone mechanical flow meter. It can be activated in rare instances of electronics because these are independent of power switch. So oxygen flush, oxygen flow meter can be used. Flow control valve assembly. This will be subsequently covered by Sunaina ma'am in her subsequent lecture. But just in nutshell, it allows use of low flow oxygen device independent of breathing circuit. It has a flow control knob, the needle, the oxygen flow inlet, and the float stops. Only the thing which I'll try to stress upon is the color coding of it, and the oxygen one is serrated, fluted, and for tactile, it is large in shape. So tactile discrimination can be easily made through it. So like we have like in traditionally, we used to have the flow meter assembly. Then in Draeger primers, we have the electronic ones, and this is the hybrid one. The standalone, this thing is there, flow meter assembly, and this is color-coded knobs are there with this safety device serration so that automatically it doesn't get open or closed. So that is it for my intermediate pressure. We just have to remember the diagram and we're done. Thank you so much.
Sorry, we have to switch back and forth because we are still in the hospital. Okay, so did you stop sharing? Okay. So thank you, Dr. Shikha, for a comprehensive coverage of the intermediate part of the anesthesia workstation, intermediate pressure, I would say. So can we launch the poll for the next?
Yes, ma'am.
Okay, so is there some problem with the poll?
Ma'am, if you shared the question of the poll so that I can launch the third session's poll.
Okay, just 1 minute. Just
Okay, ma'am. You can take your time.
Let me share my screen. I will just.
Sure, ma'am. I'll wait.
Yeah. So we are switching back and forth between the presentations. So that is why it is taking a little time. Okay.
Not an issue, ma'am.
So we will now go on to the third part of this webinar. So can you see my screen?
Yes, ma'am. So here I am launching the first question.
So yeah, so before we move on to the seminar, to the webinar, I mean the third part of the webinar. So here's the first question. All statements regarding anesthetic gas scavenging system are true except option A, all connections are of 30 mm diameter. Transfer tubings in the system are same by color and configuration from that of breathing gases. Option C, negative pressure relief valve is needed in active scavenging system. Option D, positive pressure relief valve is needed in a passive system.
So, ma'am, should I end the poll because the time is already over?
Yes, please.
Okay, ma'am. Can we move on to the next poll?
Yes. So, question 2. The connections of the scavenging tubes have a diameter of option A, 15 mm, option B, 22 mm, option C, 30 mm, and option D, 15 mm inside and 22 mm on the outside.
So the time is almost over.
Okay. So going on to the third question. The oxygen flow meter in the flow meter assembly should be positioned option A, upstream, option B, downstream, option C, in between air and nitrous oxide, and option D, doesn't matter.
Five seconds left. And the time is over.
So coming to question 4, which of the following statements is false about the mechanical oxygen flow control in the flow meter assembly? It has fine serrations, option A, option B, most protruding, option C, it is the largest, and option D, it is protected by a shield bar.
10 seconds left. And the time is over.
So going on to the last, I think the second last question of this poll, the Link 25 system is all except option A, 90% pneumatic and 10% mechanical. Option B, 10% pneumatic and 90% mechanical. I think there's a slight error in this. Option A and B both seem to be the same. So that's okay. Then option C, maintains oxygen and nitrous in a ratio of 1:3. And option 4, present in detectometer anesthesia machine.
So here I am ending the poll because the time is already over. So here comes the last question of session 3. Ma'am, should I launch the poll?
Yes, please. So the last question, the selected tech mechanism of the vaporizer manifold allows only one vaporizer dial to be turned on at a time, option A. Option B is not foolproof. Option C, neither of the above. Option D, both of the above.
And the time is over.
Okay, so we will discuss all the question and answers at the end, as we discussed earlier. So with this, I would like to request Dr. Sunaina Karna to please share her screen.
Thank you, Dr. Zainab. I'll be able to share my screen once. Yeah.
Can you go on
So,
stage?
am I
Yeah.
visible?
Yeah. So
Yes,
before
ma'am, it is visible.
So before we start, I would like to introduce Dr. Sunaina Karna, who's another very good friend and senior of mine. She's an additional professor at the Department of Anesthesiology at AIIMS Bhopal. And she's a very good anesthesiologist, very active and dynamic person. And her areas of interest are transplant anesthesia, difficult airway, pediatric anesthesia, viscoelastic point of testing, point of care testing, and simulation. And she has a lot of publications. She has a very good citation index. So over to you, Sunaina ma'am, and she will be speaking on the safety features of the low pressure part of the anesthesia workstation.
Thank you, Dr. Zainab, for the introduction. And I would also like to express my gratitude to Dr. Sanish sir and Professor Radhakrishnan sir for asking AIMS Bhopal team to conduct this webinar. We are delighted to do so on this prestigious platform. Going on to the next talk in this webinar. So we have seen the high pressure and the intermediate pressure systems. Let us move on to the low pressure system. You have seen this figure multiple times till now, and the low pressure system starts downstream of the flow control valves. It contains the flow meter, the calibrated vaporizer, the back pressure bar, the manifold where the vaporizers are mounted, the check valves, pop-off valves, and the common gas outlet, right? Dr. Shikha has elaborated upon the flow control valve. I will touch upon it again because it is an important part of the flow meter assembly. So you see, the physics has been told to you. If you look at the flow meter and the flow meter assembly, the flow meter knob, you understand that what it has is it has a knob, it has a stem, it has a valve seat and a side tube. So the side tubes may be multiple. There may be 2 side tubes for one gas, but the knob is single. So the safety feature is that there is nothing to confuse you. There is a single knob for a single gas, and it has a fixed movement. It will always open counterclockwise. It will close clockwise. So even if there is no light, your hand on the knob, you should know how it is going to move and how the gas is going to flow, right? It is color-coded. It is color-coded. You can see the blue color for nitrous, air, black and white for oxygen. And the oxygen knob is the largest. It has wide flutes. It is protruding 2 millimeters more than the other knobs. And there is a distance of 25 millimeters or 2.5 centimeters between 2 knobs, so that when you are moving one, the other doesn't get rotated accidentally. The nitrous oxide knob, of course, is smaller. It is more inwards and it has fine serrations besides being color-coded. And other than being located slightly apart, there is some shield or some bar, like Dr. Shikha had shown, to prevent accidental rotation of the knobs. And they are not located at the working space. They are located slightly above the working surface, so that when you're picking something up, some syringe, some drug from the tray, you don't end up turning the knobs. Coming to the flow meter sub-assembly, the other thing which I talked about is the side tube. In this diagram, you see that there are 2 tubes. Why? Because one is for low flows, the other one is for high flows, 1 liter onwards. But they are in series. See, you read it from bottom to top, and again you start reading from the bottom to top. So the last reading is where you know how much flow is kept. And when there are 2 tubes present, there is a single taper in that tube. But when there is a single tube present, because you want to give low flows, you want to give high flows, so there is going to be a double taper in that particular tube. So what are the safety features in a TOPS tube or this side tube, which I was talking about? It is made up of borosilicate plexiglass. And since it is transparent, you can see across, right? You can see the bobbin floating in it. You can see the scales. You can see the back panel. And we have to understand that the flow meter assembly is calibrated very carefully at 20 degrees centigrade and at atmospheric pressure. And it is calibrated for each single gas. You cannot interchange the nitrous oxide side tube with the oxygen side tube. In some machines, there is a pin index system at both ends of the tube, so as in order to enable correct fitting. There is a fluorescent coating at the back panel. Even if there is no light, lights goes off, you can see what is what. There are color coding of white for oxygen, blue for nitrous in the back panel. And to prevent leakage, like we had seen in the hanger yoke assembly, in Dr. Zainab's lecture, there is a neoprene O-ring washer at both ends of the side tube, even in the flow meter assembly. And another important safety component are the stops. Stops are present at the bottom so that when you are closing it off, the bobbin doesn't damage the valve seat, which is present at the bottom. And when you're increasing the flows, it doesn't get stuck at the top, so that you're not able to see the bobbin, or there is a leakage, or it goes further apart. So that is what helps you in seeing the bobbin in the side tube. Besides that, we don't want the bobbin to get stuck to the side tube because of static electricity, right? So what is done to prevent that? The safety feature is there is a Crockstein box spray available in aerosol can. It is sprayed on the inner and outer surface of the side tube. So all of these safety features of the TOPS tube or the rotameter tube or the flow meter tube, they help us in ensuring that we know what we are delivering and how much we are delivering. Coming on to the bobbin, it can be a skirted float bobbin or ball bobbin. So whenever you turn the knob anti-clockwise, the gas starts flowing. It pushes the bobbin upwards. Gravity tends to push it downwards. And that is how it is balanced in between. So as you turn the knob more anti-clockwise, more gas flows, it goes further up. In the lower part of the tube, when the gas flow is less, the flow is laminar. And what governs the gas flows are the Hagen-Poiseuille's law, which depends upon the viscosity of the gas. Higher up, what determines the gas flow is because, see, more angular spaces are available higher up because it is a higher flow. So at that particular point of time, the flow may get turbulent. Once it gets turbulent, what determines the force is the Graham's law. So here, the flow will depend upon the density of the gas. A little physics. It is a very common question asked in exams, especially the Viva. Examiners love it. Coming back to the sweet little bobbin, so you have veins or fluid at the top of the skirted float. See, it helps in, when the gas moves through it, it helps in rotating the bobbin, and you can see the rotation. Another feature which helps you in looking at the rotation is the fluorescent mark. So there is a fluorescent dot here, which when it rotates, you can see that, okay, the bobbin is moving. If it is a ball type bobbin, it is colored in two parts. Half is blue, half is yellow, so that you can differentiate that the bobbin is floating. And of course, the stops make sure that the bobbin is visible at all points of time. So this was about the flow meter subassembly. Is it the arrangement of flow meters significant? See, the position of oxygen flow meter in the US workstations is to the right. In the United Kingdom's workstation, it is more to the left of the flow meter panel. But what is important for us to understand is that the position of oxygen flow meter should be downstream or last. Why? See, if you look at this, nitrous is downstream, air in the middle, oxygen upstream. Any leak in oxygen, any leak in the air tube, what happens is patient gets nitrous and this gets diluted through the leak. Similarly, if the nitrous is downstream, any leak in the air tube, oxygen goes back towards the air because that is the path of least resistance, goes forward, you're not able to govern what is going to the patient. So oxygen being downstream helps because here you are quite sure that, okay, if something happens upstream, still oxygen is there. But is it foolproof? Does it solve all your problem? No, because even then, if there is a leak in the oxygen flow meter tube, still nitrous can go. So you have to, ultimate safety feature is what? It is the oxygen analyzer, the common gas outlet, which tells you how much oxygen you are giving, right? Auxiliary oxygen flow meter, Dr. Shikha has already told about. One important point, it can be used for para-oxygenation. It can be used to connect an ambu. It is usually present to the left side of the machine. Now we have come a long way from the Boyle's machine. When I was a PG, we had Boyle's machine in our operation theaters. Now it is only kept during examinations. We have come on to the workstations. So this is the Draeger Primus workstation. Can you see the flow meter assembly here? Can you see the tubes? No. Dr. Shikha had mentioned we have electronic controls now. Some workstations have transitional hybrid controls in which the knob may be needle valve, but the display is still electronic. And in a purely electronic control, you have electronic valves and electronic display. So here, what do you set? You set up what you want to give with oxygen. You want to give nitrous or you want to give air. You set up the FiO2, you set up the total fresh gas flow. And that helps you in giving the agent. Now there are intelligent machines available, GE, ICIS machine. Here, there is a sensor which tells you about the internal control of oxygen and anesthetic agent. So this is target controlled delivery of anesthetic vapor. Why are we talking about electronics? Why? Because it is quick. It decreases the workload of the anesthetist. You are able to deliver low flows more effectively. So you use less agent, less environmental pollution, more cost effective, right? Coming to the other part, which is the hypoxia prevention devices. In many workstations, once the master switch is on, a minimum flow rate of 50 to 250 mLs per minute gets started. That is the mandatory minimum oxygen flow. So that is one hypoxia prevention device. There are, of course, alarms in which if you have set the oxygen less than desired, this alarm starts beeping. And then there is, of course, the minimum oxygen ratio proportioning device. Here, if the oxygen concentration is more than 25%, you can set the levels, whatever FiO2 you want. But once the FiO2 starts going less than 25%, the gases get connected. This I'm talking about nitrous and oxygen. So there may be a mechanical linkage or an electronic linkage. Anesthesia workstation standards say that any anesthesia workstation must be provided that protects against a user selection of a gas mixture with oxygen concentration less than 21%. And ASTM standards dictate it should definitely not go less than 19%. Coming on to link 25, I'm sure you have seen bicycles with this figure. See, there are two wheels which have sprockets in them, and there is a chain across. So this similar mechanism is present in the flow control valves of oxygen and nitrous. This is nitrous, this is oxygen. We can identify because this is the wider, more polluted valve, bigger, more protruding. Now, what happens is that the nitrous valve has 14 teeth, the oxygen valve has 28 teeth. So 2 times movement of nitrous will automatically cause 1 time movement of oxygen when the oxygen concentration is less than 25%, because a needle or a pin is activated which mechanically links these two once the oxygen concentration is less than 25%. Still, that makes up only 1:2. You can increase oxygen 1 time for every 2 times increase in nitrous. What about the rest? See, look at the pressures. For nitrous, the pressure is 26 psig, and for oxygen, it is 14 psig. So this pressure also contributes to the protection. So this mechanism is present in GE and Datix Omeda machines, and it is 90% mechanical, 10% is pneumatic because of this pressure differential which is being delivered. And the ratio of flow of nitrous oxygen cannot be more than 3:1. If you start to decrease oxygen less than that, nitrous will also decrease. So that is that. Coming on to the sensitive oxygen ratio controller, this is SORC present in Draeger. Here you see the flow meter tubes. This is oxygen, this is nitrous. There are resistors in this tube, flow meter tube. The resistor value of oxygen flow meter is 3 to 4 times that of nitrous. You can see the oxygen chamber, the nitrous chamber. You can see the mobile horizontal shaft. Whenever oxygen flow increases, it pushes against this diaphragm in the oxygen chamber, pushes the mobile horizontal shaft, which pushes the nitrous oxide diaphragm, opens the slave nitrous oxide control valve, allows nitrous oxide to enter. As simple as that. So it's a proportional mechanism. It delivers an FiO2 of 25% and more. Now, these were the mechanical linkages. There are also electronic linkages in devices like Penlon, where there is a paramagnetic oxygen analyzer, which continuously samples gas mixtures from the flow meters. So if FiO2 is again going below 25%, nitrous oxide is temporarily cut off. So this ends up supplying more than 25% or minimum 25% FiO2. Are they foolproof? Even they are not foolproof, because if you're supplying the wrong gas, if any one part of the pneumatic, mechanical, or electrical component is damaged, or if there is any leak downstream of the flow control valve, or if you're giving some gas other than oxygen nitrous, or if you're using very low flows, you say you're using metabolic flow rates 0.35, or using minimal flow rates 500 mL per minute. In that case, what happens is that the patient consumption is more than the oxygen delivery. So you can still end up giving a hypoxic mixture. So please, whenever you're giving low flow anesthesia, read about low flow anesthesia, how much time you have to give at 4 to 6 liters per minute before you can directly jump onto lower flow rates, right? Coming on to vaporizers. We have come a long way from the Goldman's bottle to the Tech 5, 6, 7 vaporizers. We have to understand vaporizers are error prone. That is why all these modifications have been made. In fact, if you install it wrongly, it can lead to loss of fresh gas flow. If you give a wrong agent, if you're simultaneously using multiple agents, if you tip the vaporizer, the gas channel fills with liquid agent during transport, you can end up overdosing the patient with the anesthetic agent. So to prevent this, various safety mechanisms are proposed. All the vaporizers are color-coded. Orange is for enfluorine, yellow for sevoflurane, purple iso, red halothane, and blue for desflurane. So this color coding is present on the concentration dial at the front where filling is done, and at the where you can see the indicator levels. And you have agent-specific filling mechanisms, which can be a keyed filler or a pore fill system, quick fill, which is present for sevoflurane or easy fill. You cannot randomly open the dial, concentration dial. You have to push this push release button. Only then you can intentionally open the concentration dial. Then there is a selector tech mechanism in Omeda and interlock mechanism in Draeger. In this, if you see, these are the two male valve posts. And they have those O-rings around them to prevent gas leakage. And the vaporizer has female ports, which comes and sits on this back port. And once you open the dial, a plunger gets emitted from the side, which prevents movement of the concentration dial of the next vaporizer. So if you see here, this is open, isoflurane is open, the valve is turned. So these are locked by the plungers here, right? So at one point of time, this is a double bracket system for 3 vaporizers. So at one point of time, you can open only 1 vaporizer, but it is also not foolproof if suppose you don't have double brackets and you put 1 vaporizer on either ends of the 3 vaporizer system, then you can open them. So you have to be aware of what mechanism you have in your machine. Now, to prevent tipping, the vaporizers are heavily made. They have a heavy construction. There is a transport mode, which isolates the vaporizing chamber. There is a long vaporizer chamber inflow, so that even if it tilts a little, the agent does not go into the bypass channel. Tech 5, 6, 7 in Omida machines have a non-spill reservoir with 180 degrees allowable tilt. To prevent overfilling, the filling ports are low. And to prevent agent depletion, when you're filling, you can see where your agent is. There is a low filling mark, a high filling mark, so which guides you while filling the vaporizer. What are the safety features downstream of the back bar? There is a check valve, pop-off valve, there is a common gas outlet. Check valve lessens, but it does not prevent pressure increase. See, it is downstream to the vaporizers. It protects the vaporizers and the flow meters, right? The pop-off valve is at the extreme right, and it is a spring-loaded valve. Whenever the pressure is high because of distal occlusion, it opens. At 5 psig or at 300 centimeters of water, it pops open. That is why the name pop-off valve. If you want to use jet ventilation, it is not a feature of boils, but then some machines have intermediate pressure system supply a line for jet ventilation with which you can provide jet ventilation. Now the common gas outlet. This is the common gas outlet, the breathing tube. It has a 15 mm inner joint, female slip connector, and 22 mm outer male coaxial joint. Now here, if you see, the machine standards dictate that it should not get easily disconnected. So there has to be some retaining screw, some cap to prevent that it gets disconnected. And if suppose there is an auxiliary outlet for, say, to attach a pediatric JR circuit, and there is a closed circuit, so if there are 2 outlets, then only one can be selected at a time. So there is an interlock mechanism for the common gas outlet. Oxygen analyzer present at the common gas outlet. It is the small things that matter, as said by Emily Dickinson. So oxygen analyzer and an anesthetist who is aware about what he's doing. So it needs to be calibrated every day. It needs to be calibrated at room temperature. We have talked about oxygen control. Beware, it may or may not work through the vaporizer. So if you're using oxygen control in cases of electrical failure, the patient, and it is not going through the vaporizer, so patient may have awareness. Then you have to use TIVA. So be aware of what you have in your machine. I'll just touch upon the breathing systems. See, the circle system has its own inbuilt mechanism. There is a switch which tells you whether the patient is in manual mode or mechanical ventilation. There is a valve, APL valve, which has a pressure gauge, which tells you how much the pressure is. The valves are unidirectional and they are encased in a hood so that gases can be collected in the reservoir for scavenging. There are minimum number of connections. There is a carbon dioxide absorbent, which is color-coded. There are tests, and some parts of the breathing systems are autoclavable. The soda lime canister is autoclavable. These parts are latex-free. So all of these are, in a way, safety mechanisms, right? Coming on to the anesthesia ventilators. Anesthesia ventilators can have a bellows design or a non-bellows design, which can be a piston or a turbine design. Understand that in bellows design, there are 2 circuits going on. One is the patient gas, which is inside the bellows, and the other is the driving gas, which is outside the bellows. Here, if you have an ascending bellows, that is safer, because if there is any leak, it will collapse, but descending will not. So you have to be aware which kind of bellows design you have. Then the piston design ventilators are electrically driven. They have a single patient gas circuit. Advantage is that they give very accurate tidal volume. They are quiet, they have a greater precision, and the PEEP which is required to open pressure of ventilator spill valve in bellows design is not present here. So no auto PEEP is generated. So understand which kind of ventilator you have. Safety features in ventilators, of course, there are alarms. There are 3 disconnect alarms. There are built-in alarms. There is self-checkout. There is fresh gas compensation, which is a feedback by volume and flow sensors. These volume and flow sensors, they adjust the tidal volume in spite of fresh gas flow changes to match the set tidal volume. And there is fresh gas decoupling, which is present in piston or descending bellows. Fresh gas decoupling is what? This decouples the tidal volume from the fresh gas. So ultimately, what is being delivered to the patient? This is the inspiration phase. This is the piston ventilator. During inspiration, the decoupling valve is closed, and that causes the fresh gas to not reach the patient. So it is not contributing to the tidal volume. What is contributing to the tidal volume at this particular point of time is the gas present in the ventilator, which goes and contributes to the tidal volume. Here, the fresh gas goes into the reservoir bag. So during inspiration, as you can see, the reservoir bag is filled because fresh gas is diverted here. Whereas during expiration, this fresh gas from the reservoir bag, which was collected here, goes, because the decoupling valve is open, into the ventilator. So during expiration, the reservoir bag collapses, right? So it is at this point of time that you can see how the patient's respiration is going, how the bag is moving, how the ventilator. In this, one point of interest though is that because the fresh gas is not going directly to the patient, it does not cause barotrauma, volume trauma, but if the fresh gas flow is inadequate, air may be entrained, which can cause hypoxia, which can cause awareness. So you have to be aware of what kind of ventilator you are using in your machine. This was a very important case report in which they said that there was a leak in the absorber. So because of that, what happened is that during mechanical ventilation, they were able to ventilate the patient with the piston ventilator. But during manual ventilation, the air took the path of least resistance to the absorber leak, and they were not able to ventilate the patient. So fresh gas decoupling valve may mask leak in the mechanical ventilation. So beware about that. Coming on to the scavenging systems. Scavenging systems have a collecting system, a transfer tube, receiving system, disposal system. So collecting tubes are different. Their diameter is not 1522, it is 30 millimeters, conical connection. And they have a pressure relief valve, which in Omeda machine opens at 1 kilopascal. Then the transfer tubings are wide bore, kink resistant, they are of a different color. The receiving system, in a closed system, this is a closed system, this is an open system. So in a closed system, there is a negative pressure dumping valve, which at flow rates of 30 liters per minute opens at 0.5 centimeters of water. There is a positive pressure valve, which at flow rates of 30 liters per minute opens at 5 centimeters of water. Then most ASTM standards dictate that the scavenging system should be active. In UK, what is present is a high flow active scavenging system. In US, what is present is a low flow active scavenging system. What we have is also a fan-based scavenging system in our hospital. In Scandinavia, they have passive venturi systems. So you have to be aware of what the scavenging systems are, what are the connections, and what are the back pressures. Now, since we are short of time, I'll not be going into the integrity test, but understand that the universal negative pressure leak test should be done, which is done with the help of a pneumomanometer balloon, which if collapsed, attached to the common gas outlet with everything closed, should not inflate within 10 seconds. Then you can check it with the individual vaporizers as well. Modern anesthesia workstations have computer-controlled anesthesia systems, safety self-checkout procedures. So you can see it can check the gas delivery, the ventilators, the monitors, the breathing systems. So it really helps you out, right? Now, in my time, we used to see street hawk. Kids nowadays look at Batman and Batcar. But the Batcar may be sophisticated, but if the man cannot operate it, no point having all the sophistications. So evolution of anesthesia workstation is driven by safety standards. But we have to understand that different workstations are diverse. So you have to be familiar with the basic concepts, the pre-used checklist, regular inspection, and you have to understand that you have to maintain these machines. All the high-end gadgets need to be maintained, right? These are my references, and thank you so much.
Thank you, Dr. Sunaina, for a very, very good lecture, a very comprehensive session on the safety features. We would have loved to hear more, but since we are short of time, probably we can invite her another time to hear her thoughts on another topic. For the next session, which is obsolescence, the criteria for obsolescence, I would like to invite another colleague of mine, Dr. Pooja Singh, who is also an additional professor. So I will just share her CV. I have. Dr. Pooja Singh is an additional professor at AIIMS Bhopal. She also has a lot of publications, 3 chapters. Her citation index is very high. She recently received the Copes Award for Best Oral Paper in the last Indian Society of Anesthesiologists National Conference. Her areas of interest are TEE, pediatric cardiac anesthesia, and difficult airway. So Dr. Pooja Singh will be talking on obsolescence and a few other safety features. May I invite Dr. Pooja Singh to start her screen?
Dr. Zainab, you have not
Yes.
started the pre-test session, I think. You forgot to give the pretest for this session.
Yes, you're right. 1 second. Again, I'm switching back and forth. Okay, so should I share my screen again?
Yes, ma'am, you can.
Okay, so thank you, Dr. Pooja, for reminding me of that. So coming to the pretest for the last session. So question 1, mark the true statement of the following. Anesthesia workstations can be labeled as obsolete if option A, it is manufactured 5 years ago. Option B, it is manufactured 10 years ago. C, if it is manufactured 15 years ago. And option D, age is not a criterion for obsolescence.
10 seconds left. And the time is over. You can launch the second question.
Yes. So it says my screen sharing is paused. Have you paused it?
No, ma'am. Maybe it got paused from your end. Again,
Okay.
click on that pause option. It will resume.
No, it is. I cannot share it now. I don't know why it's stuck.
Okay, ma'am. Will you be able to read
Can you
it
do
out
it for
from
me?
my? Ma'am, can you read it out from the polls?
Okay. But that will not be visible, right? To everyone. So I just to the people who are on phone. So
Okay,
have
okay,
you?
ma'am.
Okay. So can you just help me do the screen sharing?
Ma'am, screen sharing of what, ma'am?
My screen. Can you help me? It says that it has been paused.
Okay, okay, I'm sharing it.
Yeah.
And ma'am, for this question, should I end the poll?
Yes. Please end the poll for
Okay.
this, and we will go on to the next.
So actually, if I share the screen of the questions, so then ma'am, I won't be able to launch the poll at the same time, simultaneously.
Rupsa, just stop the screen share for the time being. We'll redo that.
Okay, 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 sir, I understand.
Okay. So we go on to the next question. Absolute criteria for obsolescence of anesthesia workstation include all except option A, absence of oxygen nitrous vaporizer in interlock device. Option B, inability. So, sorry, you are on question 3. Can we go back to question 2?
Dr.
Okay.
Zainab, can you do the screen share again? Question 2.
Just 1 second. There is some, earlier it was working fine. I don't know why. So we've just,
Yes, ma'am, your screen is again visible.
it's visible now?
Yes.
Okay, so we are on question 2, right?
No, ma'am, I have launched the question 3. Relative criteria.
I think you might as well go on ahead with question 3 and then go back to question 2.
Okay.
Yes, ma'am,
So
we can do
question
that.
3 is relative criteria for obsolescence of anesthesia workstation are all except
Ma'am,
option A.
you change your slide, ma'am. You're in slide 2. Question 2.
No, I'm on question 3. Can you see my slide?
No, ma'am. We can see question 2.
Sunaina ma'am, can you see my slide? Question 3?
What I can see is question 2. So I guess you can move on to question 3. Or you can repeat the question 2 because we can see that. If you want, I can read
Yes,
it out.
yes.
Yeah, if you can read it out. I think there's some lag on my end.
So the second question of session 4 is absolute criteria for obsolescence of anesthesia workstation include all except absence of oxygen and nitrous oxide portioning system, anesthesia machine. The second option is anesthesia machine that cannot accept vaporizers for newer potent inhaled volatile agents. The third option is vaporizer with rotary concentration dials such that the anesthetic vapor concentration increases when the dial is turned clockwise. Option D, adequate maintenance is no longer possible. So it is all except you have to choose. Going on to question 3, Dr. Zainab, you can share that.
Ma'am, my screen has been paused again. So I think there's some problem with the poll when it is being launched. So can you read the next poll as well, the next question?
Share the third question. Conduct the poll of the third question, Rupsa, please.
I
Thank you.
have shared, ma'am.
So the third question is relative criteria for obsolescence of anesthesia workstation include all except, this is a single choice question, absence of vaporizer interlock device, inability to isolate the adjustable pressure limiting valve during mechanical ventilation, absence of anti-disconnection device at the fresh gas outlet, and the last option is oxygen flow control knob that has finer serrations and smaller than the other flow control knobs.
And the time is over. Ma'am, may I launch the last question?
Yes, please.
It has been launched.
The question number 4 is, all of the following are desirable safety features of newer anesthesia machines except option A, fresh gas decoupling, option B, electronic selection of ventilation parameters, option C, different on-off switch for electrical power to integral monitors and alarms, option D, reduced external connections.
Recording in progress.
So the time is over and I'm ending the poll.
Okay, right.
So Dr. Zainab, I think you have to stop sharing the screen.
My controls are all gone. I have no idea what is going on. Anyway, Rupsa, can you stop
Yes, ma'am,
my
ma'am.
screen?
Yes,
I think
ma'am.
you need to stop your screen.
Yes, ma'am. I'm
My screen is
stopping
already
your
full.
screen from my end. It
Okay.
has been stopped.
Okay. So I would like to hand over the proceedings to Dr. Pooja. As I've already introduced her, she is an additional professor at AIIMS Bhopal. She will be speaking on obsolescence. So you can start your screen sharing.
Just a minute. Is it visible? Actually, I was stuck up in an emergency case, so I have pre-recorded my session. So I'll start from the beginning.
So it's not visible yet.
Before initiating, is it not visible?
No.
I would like to thank the ICA team and okay. So before starting, is it not visible, Zainab?
No, it's not visible. Anybody else can see? Dr. Sunaina, can you see?
No, dear, it's not visible. I think, Pooja, if you can share your PPT and start. If the
I have
video is
shared, I have already shared with Dr. Zainab, I think.
No, would you like to present live then, since I'm unable to load your presentation?
It
Can you
is
please
actually,
live
it
sharing
is
again?
not, I have saved it as a slideshow. I mean, it's a kind of a, what do we say?
Ma'am, are you facing any issue with the sharing process?
No, I think, is it visible now? It is
No,
visible.
ma'am, it is not
Screen.
yet visible, ma'am.
Can
Ma'am,
you go
have
to
you,
your presentation and then present it live?
Actually, I don't have my presentation without my video. So it will be like, my video will run at the background. So
that
there
is
will
okay.
be sounds.
ma'am, should I guide you out with the sharing process?
Yeah, sure. Tell me.
Okay, ma'am. So I prefer at first you just open the PPT in the background and then just minimize it. And after doing that, you just come back to the Zoom room, and in the Zoom room, you can see one option, share screen, the green colored option at the bottom. Just click on that and then you can find 4 options like basic, advanced, files, and apps. So just click
Yes.
on the basic. Do not go to the advanced. Just
Okay.
by clicking on the basic, you can. I hope you will be able to see. Yes, ma'am. This is what I was saying. Now just open your PPT.
Yes.
I mean, your whole screen is
Now?
visible. Yes, ma'am. It is visible.
Okay. Is it visible now?
Yes, it is visible.
Perfectly visible.
Okay, thank you. Good evening, everyone. Before initiating my presentation, I would like to thank ICA team and Dr. Zainab for giving me this opportunity. So, till now, we have learned about the functioning of the anesthesia workstation in the previous lectures. And now I would like to talk about the safety features which are absolutely required and desired in an anesthesia machine, and the lack of which can label it as obsolete. So we are going to read about the obsolescence criteria for anesthesia workstation. So before starting with my presentation, I would like to flash some disclaimers. That is that there is no conflict of interest, and all the images which are being shown in this presentation are taken from the internet, and these are used just for education purpose. And we do not endorse or discredit any particular anesthesia machine or any particular company. And all these recommendations are based on the American Society of Anesthesiologists Committee on Equipment and Facilities, which was put forward in 2004. And also, some points have been taken from the position statement on the minimum safety requirement for anesthesia machine and workstations for clinical practices, and it has been put forward in 2021. So the first thing is, what is the purpose of these criteria? So the first and the foremost purpose of these obsolescence criteria is to assist and guide the practitioners as well as the administrator and regulatory bodies to determine whether the machine has become obsolete or not. And it also specifies some minimum safety requirements for an anesthesia machine to function in a clinical scenarios. So first thing is when to label an anesthesia machine as an obsolete. So when the essential component of the anesthesia workstation has worn out or those cannot be replaced, then there are certain medical practices which have changed over the period of time. Or if there is a change in the training and experience of the anesthesia providers. Okay. And if there is a development of any new and important safety features. So next comes the question when not to label an anesthesia machine obsolete. So the machine should not be considered obsolete solely because of a certain arbitrary age. So machine or any anesthesia workstation, if it is old, it should not be considered obsolete. So, or if the date of manufacture of that anesthesia machine is earlier than some published equipment standard. That means if the machine has been manufactured in a previous date or quite earlier than the published equipment standard. So what I mean to say that it is the responsibility of the anesthesia provider to determine if the machine's failure to meet the newer standard, they represent a sufficient threat to the patient's safety to render the machine obsolete. Now, coming to the particular criteria which are required for labeling the machine as obsolete. So, any anesthesia machine or workstation can be considered obsolete if any of the following absolute criteria apply. So, if the anesthesia machine lacks certain essential safety features like oxygen nitrous proportioning system, which is a very important safety mechanism, And it is present in almost all the anesthesia machine as well as the workstation. So different kind of anesthesia machine, they have different kind of devices. Like Detix Omeda has Link 25 system, which is a mechanical device where a chain is used to link the flow control valve for oxygen and nitrous oxide. This system also sometimes fail to account for other gases such as air when the oxygen concentration has reduced to less than 25%. Then comes the dragger machine, which has a pneumatic device, which is also known as a sensitive oxygen ratio controller. It uses a ratio mixer valve. Here the oxygen is supplied to this valve. It exerts a pressure on one side of the diaphragm, which is opposed by the pressure of nitrous oxide on the opposite side. So the diaphragm is constructed in such a way which ensures an increase in the oxygen flow rate by the ratio of 25% of any increase in the nitrous oxide flow rate. Then lastly comes the electronic devices, which uses a paramagnetic oxygen analyzer to continuously sample the gas mixture from the flow meter. So if the inspired oxygen fraction, it decreases below 25%, then the nitrous oxide is temporarily cut off. So next is the oxygen failure safety device, or it is also known as fail-safe device. So we all know that the most serious catastrophe which can occur during workstation operation is depletion of an oxygen supply, resulting in a delivery of hypoxic mixture. So this can occur with cylinder as well as with the piped gas supplies. So the fail-safe device, it ensures that whenever the oxygen pressure is reduced, so the oxygen concentration shall not decrease at the common gas outlet until the flow completely ceases. And the oxygen fail-safe valve is designed in such a way so that the nitrous oxide supply will be turned off automatically when the oxygen delivery is compromised or depleted. Then comes the oxygen supply pressure failure alarm. Okay, so obviously the purpose of this alarm is to alert the anesthesiologist of the failure of the central oxygen supply so that the appropriate measures can be taken up, like opening of a cylinder, or we can reduce the use of oxygen, or we can obtain additional cylinders. Then comes the vaporizer interlock device. So most of the modern vaporizer, or also known as tech vaporizers, they has selector tech interlocking mechanism, which allows only one vaporizer to be used at a time, because turning on two vaporizers simultaneously can result in dangerously high anesthetic vapor concentration. But this criteria does not apply in an anesthesia machine that allows only one vaporizer to be mounted at a time. Then comes the pin index safety system. As we all know, this is a very important safety measure, and this is needed to prevent mounting of a cylinder in an incorrect yaw, and thus prevent incorrect gas to be delivered to the patient. So different cylinders with different gases, they have different pin numbers. Okay. Like oxygen has 2,5, nitrous has 3,5, and so on and so forth. Then comes the another safety feature, which is also known as diameter index safety system. So it is a non-interchangeable gas-specific connectors on the gas pipeline inlet, and these connectors are needed to prevent attachment of the incorrect gas delivery hose to the machine. So this is the diameter index safety system. Then one of the new criteria which have been put forward is the display of the gas supply line and the cylinder pressure on the anesthesia workstation. So this pressure display must be visible from the front of the machine, either continuously or on demand. So few machines have this kind of gauges, as it is seen in this picture, to display the pressure, while other can display electronically on the monitor screen. Then there are certain features which are considered unacceptable if those are present in an anesthesia workstation, and which which can be used to render the machine obsolete. So these features are such as the use of a measured flow vaporizer. So we can see in these two pictures, the first is a copper kettle vaporizer and another picture is of Vernitrol vaporizer. So these are a very obsolete vaporizer, and these have not been manufactured for quite some time, and servicing is also not available. So many anesthesia providers, they are not sufficiently familiar with them to use them correctly, and it may result in delivery of inadequately low or dangerously high anesthetic vapor concentration. And some of these vaporizers, they also lack the side fill features needed to prevent the accidental overfilling and spilling of the liquid anesthetic into the breathing circuit. Then most of the recent or modern vaporizer which are manufactured in the recent years, these are designed to deliver increased vapor concentration when the dial is turned counterclockwise. So if the vaporizer has a dial such that the anesthetic vapor concentration increases when the dial is turned clockwise, that vaporizer will be considered as an obsolete. That machine will be considered obsolete. However, we can replace that particular vaporizer as well. So uniformity in vaporizer control will also help in preventing the errors, and it will increase the safety. Another very important feature is to have more than one flow control knob for a single gas delivered to a common gas outlet of the machine. So having more than one flow control knob for a gas, it may result in confusion as well as unintended high or low flow of a gas being delivered. So all the modern anesthesia workstation, they have flow meters which are placed in series with one flow control knob for each gas which is being delivered to the anesthesia common gas outlet. Then coming to the scavenging system. So the connections in the scavenging system, if they should not be same as that of the breathing system connection. So if the connection in the scavenging system is same as the diameter as in the breathing system, then that is considered very dangerous and it is not a desirable feature. Why? Because having a 15 or 20 mm diameter connection in the scavenging system, it can result in incorrect connection between the breathing system and the scavenging system, and it can in turn result in very high negative pressure in the breathing system. So according to the current standard, a 30 mm passive scavenging connector is preferred along with the 19 mm hose in the scavenging system. So another very important point in obsolescence criteria is that if we are using a workstation whose adequate maintenance is not possible because neither by the manufacturer of the workstation or by the certified service personnel, and any replacement part which is required in a workstation, it should be of a suitable quality and it should not be a local made part. And another thing is that the repair or the maintenance, it should also involve the testing of the key safety as well as the performance parameters prior to the patient use. And another point is that the maintenance record and the problem log must also be kept for all the anesthesia machine in clinical use. And the machine should be replaced if more than 6 months have passed from the date of last record of the compliance. Then comes some criteria which are desirable in the anesthesia workstation, and these criteria can be used to label the machine obsolete considering the safety of the patient and the requirement of the anesthesia providers. So if the machine lacks certain safety features such as the means to isolate APL valve during the mechanical ventilation, So, what is the function of APL valve? APL valve is designed for use with manual ventilation. It allows excess gas to escape when a certain set pressure is exceeded, and this helps in minimizing the risk of barotrauma to the patient. If the APL valve is accidentally left open, then what will happen? During the mechanical ventilation, the gas will escape to the scavenging system and the patient might be hypoventilated. So this will mean that the delivered tidal volume might be considerably less than the set which is being set on the ventilator. So isolation of the apical valve can be done both mechanically as well as electronically based on the type of workstation we are using. Then comes the flow control knobs, the oxygen flow control knobs. So the current standard mandate is that the oxygen flow control knob should be larger than the other flow control knobs and it should be fluted. And this helps the anesthesia provider to make alteration to the gas flow during low light condition as well. And when the anesthesia provider is not directly looking at the machine. So it also provides a tactile identification of the oxygen flow control knob. It helps in reducing errors. So we can see these are the older machine where this feature was not present, while these are the this kind of the oxygen fluted and the larger oxygen knob is present in the new anesthesia machines. Then comes the another point, that is when the oxygen flow control knob should be placed downstream. Why it is important? To prevent the delivery of hypoxic mixture if there is some leak is there in the flow meter assembly. Now coming to the oxygen flush valve. So this oxygen flush valve provides very high volume of the fresh gas flow and it should be protected from the accidental activation. Why accidental activation of the oxygen flush is important? Why? Because it can result in the barotrauma. Okay, and the protection can be provided either by the placement or by the design of the control. So it should be usually placed in the recessed setting like this, and it should deactivate as soon as the finger activating the switch is removed. So most of the anesthesia machine has this kind of oxygen flush valve, and these are the older flush valve in the older machines where this is a push button kind of an oxygen flush and this is a rotatory oxygen flush. Another important feature is anti-disconnection device at the fresh gas outlet. So disconnection of the fresh gas inflow to the breathing system might lead to undesirable anesthetics or oxygen concentration delivered to the patient, and it can also create a significant leak in the breathing system with rapid loss of gas. So depending upon the mode of ventilation, the disconnection of the fresh gas hose may not be immediately apparent. Therefore, in the older machine, this kind of safety mechanism was used, which used to be turned towards the common gas outlet, which is hooked, and it led to the prevention of the disconnection of the common gas outlet hose. Then comes the airway pressure alarm. These pressure alarm can detect the sustained positive pressure as well as the negative pressure. And these pressure condition, as we all know, they represent an immediate threat to the patient safety, and they need to be brought to the immediate attention to the anesthesia provider. And these alarm can also detect disconnection through low pressure alarm, and it is a criteria for ASA standard for basic anesthetic monitoring. Another very important feature is that the main on-off switch of electrical power, it should supply power to the integrated monitor as well as the alarm. So the current standard maintains that the main power switch, when it is turned on, it should enable the integrated monitors and the alarms as well. So these are the kind of electrical outlet are present at the back of the anesthesia machine, and these can be used to provide electrical power to the integrated monitors as well. So another point, another new criteria which was put forward by Australia and New Zealand College of Anesthetists is that the on-off switch must be protected from the unintended activation or deactivation. So we can see that different anesthesia machine have different kind of a main on-off switch. This is a kind of a rotatory knob, and this is a push button kind of a electrical switch. Then switching off should also require a confirmatory step. That is, it should flash a message of a shutdown, or the machine should also display a warning sign of the imminent shutdown. And in case of a shutdown, a battery backup should be present of at least 30 minutes. So another relative criteria is that if there is a significant problem with the maintenance of the machine, means that if the anesthesia workstation is so old that it requires frequent maintenance, and because of it, it cannot be used regularly and it is impacting the clinical services, then it is unsafe for patient use. Okay, and the cost of the maintenance, if it is it is coming too high, so it is uneconomical to use that kind of a machine. So what I mean to say that the anesthesia record and log should be kept for all the anesthesia machine in clinical use, and the problem of all the machines should be documented, and these records should be reviewed regularly. Then there is always a potential for human error, because older and newer machines features may cause confusion and error. Okay, like automatic activation of the monitor and alarm by the main on and off switch, because there are certain machines where there is not a single main on and off switch. Okay, the main on and off switch will open just the pneumatic part of the anesthesia machine, but not the integrated monitors and the alarm. So this can create confusion into the mind of anesthesia provider who are using newer anesthesia workstation where this is integrated. And so standardization of the machine throughout the institution should also be considered. Next is that the location of certain features may be different in different machines. For example, oxygen flush valve is present sometimes over here, then in other machine, it is present above the vaporizer, and then in some machine, it is present just adjacent to the common gas outlet. So another point is that if the machine is not able to meet the current practices, for example, the machine cannot accept vaporizer for newer porter inhaled volatile anesthetics, or the machine cannot deliver fresh gas flow very low enough for current practices, like we cannot practice low flow anesthesia through that particular anesthesia workstation, or the integrated anesthesia ventilator is not capable of safely and effectively ventilating the lung of a target population, like the pediatric population. So this means that the newer agent techniques or ventilators, those may not be compatible with the older anesthesia machine. So if we want to use the newer agent or the newer technique, then if it is considered to be necessary for the optimal patient management, then we can obviously obtain a new anesthesia machine. Now, coming to the last part, that is the scavenging system, which has several safety features according to the international standard in ASTM. We are not going to cover it in much detail, just a brief account. This scavenging system, what is their function? They scavenge the waste anesthetic gases and they prevent the OT pollution. So these scavenging system, they have negative and the pressure relief valve to make sure that no dangerous pressure are transmitted into the breathing system in the event of malfunction of the system. So as we all know, these scavenging system has basically 4 parts. That is the first is the collection part, then the transfer part, then is the receiving part, and then is the disposal system. So in the active system, when we are doing the active scavenging, so it uses a fan or a pump in the disposal system, which draws the anesthetic gases, and this pump system can develop very high pressure and can be used with the narrow tubing. So whenever we are using the active scavenging, it is mandatory to have a mechanism to protect the patient against the negative pressure. Then in the passive system, exhaust gases, they pass along with the tube through an outside wall or a window. So care should be taken so as to not to position the exterior tube in a windy position, as these high wind, they can create suction which could be transmitted to the patient. And then the transfer tubing. Okay, after we have collected the waste gases, the gases are transferred into the receiving system with the help of a transfer tubing. So these transfer tubing, they should be of different color and configuration to that of the breathing gases in order to avoid confusion. And these should be resistant to kinking, and these should be occlusion proof. They should have very low resistance to gas flow. This is a picture of an active scavenging system. So other factors which are important apart from the criteria which we have discussed previously is that the anesthesia machine, it may be rendered unsafe for clinical use for several other reasons also, including the failure to meet the electrical safety requirement or the lack of appropriate monitoring equipment. So to conclude, I would like to emphasize that with the ongoing technological advancement, we have moved from basic voice machine to more integrated workstation, and several efficient safety mechanisms have been incorporated from time to time. But the most important link between the machine and our patient is the anesthesiologist, who I think is the ultimate safety mechanism for our patient, because the consequences for the patient would depend upon the vigilance of the anesthetist. Thank you so much. Thank you for listening.
Thank you, Dr. Pooja, for that comprehensive discussion on obsolescence, and also a quick recap of some of the things that were discussed in the earlier talks.
Thank you, Dr.
So
Zainab.
before going on to the question and answer session, we would just like to discuss the answers of the pre-test questions that we held. So I will try to share my screen. So is my screen visible, Roop sir? Dr.
Yes,
Sunaina?
it is visible.
Okay. So coming to the first session. So, and the first question, which of the following is not a component of the high pressure system? So the answer to this was secondary pressure regulator. I'm sure some of you or most of you must have got this question correct. Second question, for oxygen, the primary pressure regulator regulates pressure from, so we all know the pressure in the cylinder is 2000 psig and the pressure in the intermediate system is around 50 psig. So the pressure is regulated from 2000 psig to 50 psig. So option A was correct. So which question 3, which of the following is a reclosing type of pressure relief device? So now you must have all listened to the lecture that ruptured disc, fusible plug, and combination ruptured disc and fusible plug are all non-reclosable. That means that once they are activated, they don't reclose. But the pressure relief valve, it is a reclosing type of pressure relief device. Question 4, which of the following is a property of Budok seal? So it is a non-combustible neoprene washer with a copper ring. I already discussed the properties of the Budok seal in my presentation earlier. What is the pin index for oxygen, nitrous oxide, and air? So as I told you the mnemonic, air is 1.5, oxygen is 2.5, and nitrous oxide is 3.5. So 1.5, 2.5, 3.5. So option C was the correct answer. Then coming to session 2. The first question, what is not a part of the intermediate pressure system in the anesthesia machine? The answer was flow meter assembly. So we all know that master switch, oxygen flush, flow control valve, they all belong to the intermediate pressure system. Question 2, the oxygen flush valve gets disabled when master switch is off. So this was false. We know that The oxygen flush valve, along with the auxiliary flow meter and the alternative oxygen control, they are all independent of the master switch. Question 3, the second stage pressure regulator decreases the pressure to. So we now know that the pressure in the low pressure system is 26 psig for nitrous and 14 psig for oxygen. So the answer is option B. Question 4, oxygen supply failure alarm is activated when oxygen pressure falls below a safe threshold value within 5 seconds and cannot be muted. So this is a high priority alarm and it cannot be muted. So that is why answer B. Question 5, which of the following part of the anesthesia workstation are not independent of the master switch? So again, a similar question. Answer is flow control knob. Rest of the others are independent of the master switch. Coming to section 3, all statements regarding anesthetic gas scavenging system are true except. So we know that all connections are of 30 mm diameter. This is correct. Negative pressure relief valve is needed in active scavenging and a positive pressure relief valve is needed in passive systems. So the incorrect answer is the transfer tubings are same by color and configuration. So we know they have to be different, right? The connections of the scavenging tubes have a diameter of 30 mm. This was fairly easy. So option C is the correct answer. The oxygen flow meter tube in the flow meter assembly should be positioned downstream. So as Dr. Sunaina explained to us that the flow meter should always be downstream. Oxygen flow meter should always be downstream. Which of the following statements is false about the mechanical oxygen flow control knob in the flow meter assembly? So we know that it has to have coarse serrations so that we can identify it by touch also, by tactile sensation. The link 25 system is all except. So option C and option D are correct. So it maintains oxygen nitrous in the ratio of 1:3 machine, 1:3, and it is present in latex or medo anesthesia machine. But as we listen to the lecture, it is 90% mechanical and just 10% pneumatic. The selected take mechanism of the vaporizer manifold allows only one vaporizer dial to be turned on at a time, and it is not foolproof. So the answer is both of the above, option 4. Coming to the session 4. Mark the true statement, anesthesia workstation can be labeled as obsolete. So now we know that age is not a criterion for obsolescence. So option 4. Absolute criteria for obsolescence includes all except. So if all the other are absolute criteria and option B is a relative criteria. So if it cannot accept vaporizers for newer potent inhalation, you could use an older agent. So that is why it is a relative criteria and all the others are absolute criteria. So answer is option B. Relative criteria for obsolescence of anesthesia workstation includes all except. So again, absence of vaporizer interlock device, it is an absolute criteria. So that is why the answer is option A. All of the following are desirable safety features of newer anesthesia machines except fresh gas decoupling, electronic selection, different on-off switch for electrical power to integral monitors and alarms. So we know that there should always be only be one on-off switch so that we don't miss switching on or off some important part of the workstation. So that is why the answer is option C. So to summarize, all of us should be aware of what we have in our theaters. We should know and respect our equipment. As Dr. Pooja said, we should be its master and our equipment should not be our master. Then a knowledge regarding our equipment, proper practices, and a vigilant anesthesiologist is the minimum mandatory requirement for providing safe anesthesia. So the ultimate safety, it lies with the anesthesia provider. So no matter you may have all the advancements in the world, but you have to be vigilant so that you can provide the ultimate experience, ultimate and a safe experience for your patients. So that is all from our side. I would like to hand over the proceedings. So I think we have 1 or 2 questions. We can take the questions now. Roopsa, do we have any questions? I saw some questions.
Zainab, I can see a few questions in the chat box.
Yes, yes. So I'll read out the questions. I think they are all related to the intermediate pressure system. So one question is, which one is more safe or more advanced, Link 25 or SORC? So Dr. Sunaina, would you like to answer that?
Yeah. So Link 25 is a mechanical system. It is present in GE machines and Datex Omega machines. S-ORC is sensitive oxygen ratio controller. It is present in Draeger machines. See, all machines try to give some component of hypoxia prevention device. So this is machine specific. So S-ORC is for Draeger machine. Which is better? Link 25 can be defeated if any of the mechanical components are damaged. Similarly, even S-ORC can be defeated if the diaphragm is damaged or the mobile horizontal shaft is damaged. So I guess that both of them are meant to prevent hypoxia, but ultimate safety feature is the oxygen analyzer, which is present at the common gas outlet. So you cannot actually compare two machines. It's difficult to say that.
Another question was, okay, so oxygen failure safety feature we've already covered in detail. Dr. Shikha has already covered in detail. So we have the fail-safe mechanism and we have the alarm system. So I don't think we need to discuss that again. So and last question is, will there be any gas leak if an empty vaporizer is used? So again, over to you, Dr. Sunaina.
So the beauty of the vaporizer is that when it is in zero position, what happens is the gas flows through the bypass channel, right? It doesn't go into the vaporizing channel. So as long as the vaporizer is fitted properly on the manifold and the O-rings present along the male ports are present and there is no leakage, there should not be any gas leak, right? So that is the feature of the new Tech 7, Tech 6 vaporizers, that unnecessarily gas leak will not be present if you have fitted the vaporizer properly. The bypass channel and the vaporizing channels are different, and the gas flow through them is dependent upon the turning of the concentration dial. So if it is in zero position, no. But if you are tipping it over, if you are carrying the vaporizer and you fall down, so if it is a Tech 7 vaporizer, it will still protect because it is protected against a 180-degree spill. But in older vaporizers, there is a chance that the vapor can go into the bypass channel and you can end up overdosing your patient. So you have to be aware about which kind of vaporizer you are using. But leak per se, if you have fitted it properly, it is unlikely. That is why the new vaporizers have evolved, right?
Okay, so I cannot see any other questions. Rupsa, are there any other questions?
No, ma'am. Till now, there's no other questions yet.
Okay, so before we hand over the proceedings to Dr. Radhakrishnan and Dr. Sanish, on behalf of my team, I would like to thank the entire team, Dr. Radhakrishnan, Dr. Sanish, Jayshree ma'am also I can see on the screen. Dr. Uma, thank you so much for involving us. And over to you, Dr. Radhakrishnan.
Thank you, Zainab. Thank you very much for an excellent webinar. Dr. Uma, you like to speak something?
Yes, sir.
Please.
Yes, sir.
You like to speak something?
Yes, sir. I am extremely grateful and thankful to ICA and this continued system of webinars. We are the penultimate webinar before we hit a double century next week. And that is a great achievement. And today's webinar is, in fact, one of the great learning experiences for all the postgraduate as well as established anesthesiologists, because it involves the daily bread and butter, that is the anesthesia workstation, and the important discussion about the oxygen, the alarms, the high pressure system, the low pressure system, and the fail-safe mechanism, and the various aspects of anesthesia machine safety, which have been discussed, are very pertinent, not only in the examination, but also in our day-to-day practice. And I must really congratulate the ICA and the team for selecting such a vital and interesting topic. All the speakers were excellent, and the question answers have also been answered pretty well. And thank you, Radhakrishnan sir, for joining us. And sir, kindly give the vote of thanks. Thank you, sir.
Thank you. Thank you. Dr. Sanish, you like to have a word? Are you there? I think Sanish has retired. Thank you very much, Zainab, Sunaina, Pooja, and Shikha, for giving a detailed lecture, detailed analysis of the workstations. And I don't think I ever had such a point-specific, detailed discussion on the matter. Thank you very much. And we really look forward to have some other webinar very soon from you of this sort of a standard. And once again, thank you all very much for this one. Thank you. Good night to you.
Thank you so much. Good night, sir.
Thank you.
Thank you and good night. Bye-bye.
Thank you so much, everyone, for extending us the opportunity to host a session. So,
Yeah.
with all your permission, I would like to conclude the session over here and looking forward to host you again. Thank you so much and good night.
Kripta and Clear. Thank you very much. Good
Thank
night.
you.